Hey guys, I know it sucks having homework over break, but hopefully this will make it a little bit better. There's only 3 questions, and we are just solving for irrational functions and making sure that none of those are restricted answers. So number 1 says 20 over x equals 4. So my restrictions are that x can never be 0, because if x is 0, that makes a denominator 0, and we can't have that. So here, I'm just going to multiply by both sides by the denominator. So multiply the left side by x, multiply the right side by x. I now get 20 equals 4x, because these x's cancel, or become 1 anyway. And then divide both sides by 4. And we get x is equal to 5. And since that is not one of our restrictions, that is a solid answer. Okay, so number 1, x equals 5. All right, question number 2. There are no restrictions on this because the denominator is just 7. Nothing we make x is going to change the original denominator of this function from being 7. I'm still going to multiply first both sides by the denominator, which is 7. Okay. And over here it becomes 1. And I get x plus 3 is equal to 35. Subtract 3 from both sides. And x is equal to 32. Cool. And there's no restriction, so this is also a straight up answer. Question number 3. Here, our restriction is that x can never be equal to positive 1, because if we make x positive 1, that makes my denominator 0. X can be 0 in this case because 0 minus 1 is just negative 1, and you can have negative 1 on the denominator. But we just need to make sure if we get an answer that is positive 1, we know that's an extraneous solution, or it'll be like a hole in the graph. So I'm going to do the same thing I've been doing. I'm going to multiply both sides by the denominator. It's just that this case the denominator is a bigger term. It's x minus 1. Okay, so both sides are going to get multiplied by x minus 1. And then also we actually have 2 denominators, right? So I have to multiply both sides by x minus 1, and I also have to multiply both sides by 2. Okay, and what happens is on this side, the x minus 1's cancel out, and on this side, the 2's cancel. Okay, so what I'm left with is, on the left-hand side, 2 times x plus 2. It's important that you keep these parentheses because we're going to have to distribute that 2 through. And 5 times x minus 1. All right, so this ends up being 2x plus 4 equals 5x minus 1. And we need to combine our like terms. I'm going to subtract 2 x's from both sides. I now have 4 is equal to 3x minus 1. If I add 1 to both sides, I get 5 is equal to 3x. So x must be equal to, if I divide both sides by 3, 5/3. And remember, when you're taking the SAT, you must bubble in the sheet as 5/3. If you get an answer that's 5/3, you must use 5/3. And even though that's the same as 1 and 2/3, you cannot bubble in a mixed number in your sheet. It's got to be, it must be an improper fraction like 5/3. So I get x is equal to 5/3 when I solved, and that is not equal to positive 1. So that's a good answer. Okay. All right, where are we? Oh, 4. Did I miss 3? Oh no, this was question number 3. Sorry, guys. Question number 4. So this is an interesting one. All of our denominators are 7. If all of the denominators are 7, all I'm worried about is making sure that the numerators work out, right? So if you have the same denominator, if it's a number like this, or even if it's not, we can go ahead and kind of ignore the denominator and just do this as x plus 3 plus x minus 1. And if that had been minus, you would have needed these parentheses because it would have changed all of the insides here, but it's not, is equal to 6. Now, if you wanted to check this, you can check it by, if I multiplied the entire equation by 7 by that denominator like we've been doing, every single one of these will cancel out and cancel this out. So that's kind of behind the scenes what's happening. But if all of the denominators are the same like that, every single one, you can kind of just ignore them. So let's just combine our like terms. We have 2 x's and 2 real numbers, 2 regular numbers, 2 constant values, equals 6. Subtract 2 from each side. 2x equals 4. Divide both sides by 2, and x is just equal to 2. And since there was no restrictions because we didn't have any variables on the denominator, it's just going to be a great answer. Okay, just 2. Okay, let's see. Question number 5. Question number 5. If we want to make this easier on ourselves and get rid of the denominator, because only one of our terms here has a denominator, we can just multiply. This is a great trick, you guys. We can just multiply the entire equation, every single part, by that denominator here, okay? So, and then you distribute it. 2 times 3x gives us 6x, okay? Remember, if I do the same thing to each value, I'm not changing it. And then 2 times 5x over 2, all that happens there is that the 2's cancel out. So we have 5x stays the same, but these 2's, I wanted the highlighter. This 2 and this 2 cancel out right there, and that's why we just have 5x. So that's what I originally wanted to do, was just to get rid of that denominator is equal to 22. Okay, so 5x plus 6x, we combine our like terms. We get 11x is equal to 22. And we have x is equal to 2. And again, there are no restrictions because we have no x on the denominator here. There's nothing that we cannot make the x, so that means there's no restriction. So x equals 2 is perfect. Okay. All right, next. Oh, so these both have the same denominator, you guys. So all we're worried about is making the numerators equal to each other. X squared minus 4 is equal to 12. But we do have a restriction. We need to say that x can never be negative 4, because if x is negative 4, in either of these cases, if x is negative 4, that makes my denominator 0. Okay, so my restriction is that x can never be equal to negative 4. But let's finish solving this. It's a quadratic. So, actually, we can do this. There's actually 2 ways to solve this. I'm trying to figure out the easiest way to show you guys. Well, basically what we have is, let's do this. We're going to add 4 to both sides. And x squared, I think this is the easiest way, is equal to 16. And we take the square root of both sides. And here, you guys, do not forget that the square root of 16 is both positive and negative 4. So there's 2 answers, right? We have x1 is equal to positive 4 and x2 is equal to negative 4. But have you guys noticed something? X can never be negative 4, but we got it anyway, didn't we? What that means is, do you remember the word? That this, since x is equal to negative 4, is an answer that we got. What type of answer is it? It's an extraneous solution. It's extraneous, I think that's how you spell it, solution. Okay, and what that means is in a graph, if we graphed it, whatever line this looks like, and like I can't visualize it off the top of my head, except it'll probably be something like this. Wherever x is 4, there's going to be a hole. The function is not going to exist there, but it's not going to be an asymptote. But x equals positive 4, that's going to be the real answer, okay? All right, one more. Okay, this one is interesting, you guys. the first thing you're going to want to do, somebody asked me this question. The first thing you're going to do if you have, say, like a quadratic written in standard form in a rational function, is you want to factor that, you guys. And in the real world, I'm not sure if that would matter, but for every single math question you will have up until you get to some really difficult math, it's going to really help you if you factor this. So since a is 1, it makes it real easy. I'm just looking for two numbers that add up to be 5 and multiply together to be 6. And those numbers are, so I'm just going to change the denominator to factored form. It's going to be x plus 2 times x plus 3. So you can already see something really cool happened. The denominator is actually this denominator, x plus 2, times this denominator over here, that is x plus 3, right? So that's going to make it a lot easier to finish this. But while I'm thinking of that, let's talk about our restrictions. Okay, and there's 2, right? X cannot be equal to -3, and x cannot be equal to -2. Okay, both of those are restrictions here. But what I do know is that in order to get a common denominator, all I have to do is multiply this denominator by, well, I'm going to erase this, you guys, because I need this area, x plus 3, right? And of course, so we don't have a value change, we have to multiply the numerator also by x plus 3, because that's basically just 1, so we're not changing the value here. And this denominator over here is the other denominator, it's just times x plus 2, right? And so if that's the case, then I need to multiply the numerator by x plus 2 also. And you guys, this one doesn't have to change at all because it's already x plus 2 times x plus 3. And so I'm going to rewrite this. So we have 1 times x plus 3. The numerator is just x plus 3 over x plus 3 times x plus 2, right, is equal to, and over here, I'm going to distribute that 3. Don't forget, you need to distribute if you're multiplying it. So it's 3x plus 6 over x plus 3, x plus 2. Okay. So now that we have all of the numerators, or I'm sorry, all of the denominators the same, we actually don't need them, right? We just need to make the numerators equal. So we have 3 plus x plus 3 equals 3x plus 6. So let's combine our like terms. We have 6 plus x is equal to 3x plus 6. Let's subtract x from both sides and subtract 6 from both sides. What we actually get, here, let's just do this first, subtract x, 2x plus 6. When we subtract 6 from both sides, we actually get 0 is equal to 2x. If we divide both sides by 2, we get x is equal to 0. So the solution here is x is equal to 0. That's the only way to make these work out, and it is not part of our restriction, so that's a real solution. Okay, let me know if you have any questions about these, but factoring is going to be the key to solving these equations. We'll do some more practicing when we get back from spring break. That being said, do not forget to do all of your practice SAT problems and try to fill in the bubble sheets so we can see how you did when you get back. I'll also be sending out some practice questions from those that I think are harder that you might need help with. So make good choices this week, or I hope you're having fun and staying safe, and I will see you soon.